How do you find the sum of a geometric series? Okay, so now we looked at geometric sequences. Now let's look at a geometric series. Now I put them both up this time because we need to separate all these. We have the arithmetic series, the geometric series, and we have an infinite geometric series, which we'll see tomorrow. Now, the infinite geometric series, it's not like, ooh, it's actually a lot easier to use than the geometric series. But I just don't have enough time. I want to separate the videos. So you can look at the book. It has one example for it. It's really quickly understood. All right, so here's a geometric series, and I know it's geometric because there's an n in the exponents. You see that? There's an n in the exponents, so I know this is a geometric series, and there's no other n anywhere else. Okay, so this is a geometric series. One way to do this is you can do the archaic way. You can go 4 times 0.3 raised to the 1 power plus 4 times 0.3 times, to the second power, plus 4 times 0.3 to the third power, and so on. What would be the last one in this series? 4 times 0.3 raised to the 12th power. And that would take a while, but you could do it that way, or you can use the fancy schmancy formula. I would use the fancy schmancy formula. Okay, it's S sub n equals, you guys remember it? A sub 1 times, this is the hardest one to remember.
1 minus r.
1 minus r to the n
Over 1
minus r. Look at you guys, already memorizing.
We just looked at
it. I was just looking at the... Yeah, make you guys sound awesome, then you just destroy it. Okay, so what is my n for this series? It is 12 equals, what's my first term? Ooh, that's kind of weird. How do you find the first term?
Just plug it in once.
Here it is, right here. There's your first term. It's 4 times 0.3 raised to the 1 power. Right? You just plug in the first number. And then we're going to take that and we're going to multiply it times this big old fraction right here. Now it's 1 minus, now what is the r? What is the common ratio? Doesn't this kind of like follow the pattern of the formula? The formula that looks like this, it says a sub n for a geometric series is, or sequence is a sub n times, no, I'm sorry, a sub 1 times, what is it, r raised to the n minus 1, right? Doesn't it? Okay, so that right there, r, that's your common ratio. Common ratio. Now, can you guys tell me why this is not the first term? You see this? Yeah, it says n, not n minus 1. So 4 is not the first term. This is the first term. You have to actually multiply it out. Okay? Alright, so my r is 0.3 raised to the 12th power over 1 minus 0.3. Now the part that messes students up is they don't plug it in correctly. Make sure you plug it in correctly. Okay? What I would do is I would first plug in this, because I'll get a nice pretty number, and I'll write that down. Can you guys tell me what it is? 1.2? And then I would plug in this. Alright? And then that's your answer, like in your calculator. Once you plug in that, that's your answer. Then I would say 1 minus the answer. Then I would say divided by, and then I would put this in parentheses, 1 minus 0.3, and say equals. And then get an answer. So when I did that, I got 1.42, I'm going to round it to 9. And so, but in my calculator, I don't clear the rounding. I just take that and I go times 1.2 to get my final answer, which is approximately, because I'm going to have to round here. No, not you. Approximately 1.71. And we'll do 4. Okay? So that's your sum for that series. Kind of interesting. Let's see how it starts. Like it has a 4 right there, and this number's not even bigger than 4. Weird.